Hi, in this video we are going to see a case study on crane wire rope failure. Myself Chandrasekhar, SNS College of Engineering. Before entering into the case study, just I will give you wire rope structure. So normally the wire rope consists of center part core, then it is wounded with strands. Each strand consists of wire, then the strands, number of strands together form the wire rope. Okay, this figure shows the center is core, then a smaller one is wire, then the wire is wounded together makes strand, then strand are wounded together to form the wire rope. So the case that is the failure of wire rope. So a wire rope of crane failed before the designed life hour. That is, the life hour designed for the particular crane. This crane is 5 years, but it failed at 3.5 years itself. So even before designing the wire, they consider the various stresses acting on the wire rope. Based on that only they design the wires. Then in most of the application that design is enough so that there is no such like this kind of accident happen or this kind of failure happen. But in this particular case there is an peculiar reason behind this. That is the reason that is why the wire rope gets failed. So what are the common reason for failures? Can you say? Yeah, the reasons are generally while designing a wire rope, the various stresses acting in the wire rope is considered, that is bending stress and tensile stress. So bending stress acts on the wire rope wear means it is on the pulley and drum or sleeve where the ropes are wounded. Then tensile stress is due to by means of we lifting the external elements, then tensile stress acts. So these two stresses are important for while considering the design. If we consider these two things and we design means, then there is less chance for failure. Okay, so these things are considered in the wire rope, then only they given it to the crane. But apart from that, the crane rope got failed. So there should be a reason. So we need to analyze about that failed rope. So a team went to the where the accident happened, and the macroscopic survey of wire rope was carried out by optical microscopes. So from that they found that the strand observed were loosened. So normally the strands are wounded very close together, but after the accident the microscope investigation shows that the strands are observed loosened, and some pieces of fractured wires are separated from the wire structures. So the failure condition normally indicates rope failed from fatigue after bending over small sleeves as reported. So here the failure is due to fatigue. Generally corroded surface may accelerate the fatigue failure of the rope. So corrosion may be the cause, they think, and they try to find the what is the reason. So they consider that corrosion may be the cause. And the fractured ends of the individual wires and of the wire bundles were clearly visible to the unaided eye. So it shows it's like a cup and cone shape structure, so there may be a chance for tensile failure. So that is, some of the wires failed by macroscopically ductile process, that is by tensile stress, this may happen. Meanwhile, the other wires appear to fail with a little or no macroscopic ductility. So there the few wires shows that there is no evidence for ductile failure. Okay, so what will be happen? They again analyze it. So the wire was attacked by severe rust in the area along the fractured end. However, after cleaning, the wire was found just to experience as a uniform corrosion and there was no pitting attack. So after by means of initial solution, that is nitric acid, by cleaning with the nitric acid solution of the rusted wire, they found that the corrosion is uniform corrosion. So this corrosion is not the case for fatigue failure or failure of the rope. So there may be some other reason. So they need to find the root cause of the failure. So the root cause is found out by laboratory investigation. The investigation shows that the failure of wire strands was due to the cyclic torsional stresses as characterized by the presence of fatigue cracking originated from the outer surface of the strand wire. So the main reason for this failure of rope is torsional stress. So normally we consider only bending and tensile stress for the design, but here in this case it is found that torsional stress is the reason for failure of the wire rope. Okay, so how they found it means, how this torsional stress found means, the steel wire rope move in and outer over the sheaves and touches the groove flange repeatedly. So this mechanism resulted in twisting of the rope. So that twisting resulted the torsional stresses. So it also leads to increased wear on both surface of the wire rope and sheaves grooves flange. So by continuous touching of this wire rope over the sheaves causes the wear. So this wear makes fatigue crack started at point of contact over the outer wires and small sheave grooves. So it creates number of bends and finally creating a fracture which was perpendicular to the wire axis. So from this study we can find that the reason for failure of the wire rope is not due to bending or tensile stress, it is due to torsional stress. So that occurs due to what's that, the wire rope touches the small flanges or grooves of the drum sheave. So that makes the wire to twisted, so that it makes wear and also fatigue stress, so which makes failure of the rope. So how to prevent this? So the fatigue resistance of steel wire is generally increased by increasing the number and decreasing the diameter of the outer wires of the rope. So when we insist of using like a 6x8 or 6x9 rope, we can increase the number of outer wires, that is 6x19 ropes or 6x27 ropes, like that. So this improvement goes along, however, with the reduction in ropes resistance to wear also. So we can able to prevent this kind of failure, that is due to torsion, is by, that is the torsion causes what, fatigue. So fatigue failure is avoided by increasing the number and decreasing the diameter of the outer wires, and also it improves the resistance to wear. Thank you.